spend some time talking about trigonometry. Now, I know that when I say that, many of you just ran screaming from the room. Ah! I confess that trig can be a challenging course to take in high school. However, you can take hope from the fact that trig is tested on the ACT math test at a relatively basic level. What does that mean? It means you'll be unlikely to encounter a wicked hard trig question when you take your ACT math test. Doesn't mean you can't, it just means it's unlikely that you will. Now, my observation has been that the trig questions on the ACT test are quite doable if you just know some very basic trig concepts. And even better, there aren't actually that many trig questions on the math test. You'll likely see only about 4 or so trig questions on your ACT math test, so life is good. Come on back into the room, breathe deeply, it's going to be okay. Now, as I mentioned a minute ago, trig in most high school classes tends to go quite deep. We don't have that luxury in this course. Instead, we're going to briefly review just those key trig concepts that you need to understand in order to complete the trig problems on the ACT math test. So, let's go ahead and get started. The first thing we need to do in this lesson is cover several introductory trig concepts. First of all, what is trig all about anyway? Then we're going to look at sine, then we're going to look at cosine, and then we're going to look at tangent. Now, before we start, I need to emphasize that it is very, very critical that you understand these 3 topics, especially sine, cosine, and tangent. If you don't get sine, cosine, and tangent, then you're going to struggle with the rest of the trig concepts that we're going to hit in later lessons in this course. So, make dang sure you understand this lesson before you move on, because just about all of the other trig concepts we're going to talk about in this course are going to build on this lesson. If you don't get this lesson, you're going to struggle. So let's get started. Let's begin by discussing what trig is all about. Here's the important thing you need to remember about trig. Trig is all about triangles, specifically about right triangles like this one right here. Now, it's also about circles too, to an extent. We'll talk about that in a later lesson. But primarily, when we talk about trigonometry, we're talking about triangles. Now, remember, a right triangle is one that has one angle that is exactly 90 degrees. That's this angle right here. We put this little box on that angle to indicate that it's a 90-degree angle. Now we have this other angle over here within the triangle that's represented by this Greek symbol called theta. It's a 0 with a line through it. If you see this symbol, it is called theta. And it's just kind of like a variable. It's a placeholder for whatever the real measure of this angle happens to be. We don't know what it is, so we're just going to call it theta. Here's what you need to remember, however. Theta within trigonometry is an acute angle. Doesn't mean it's good looking, it just means that that angle measures less than 90 degrees. Now understand that trig is really powerful within the realm of triangles. It can be used to calculate information about a triangle that you just can't get in any other way. Each of the triangle-related formulas that we've already talked about in this course, such as Heron's formula or the Pythagorean theorem, have their shortcomings that limit their usefulness. Many of these shortcomings, however, can be taken care of if you use trig. Now, here's a key concept that you need to remember. A right triangle is composed of 3 sides that you must absolutely, positively memorize for your ACT test. First of all, the adjacent side of a right triangle is right next to angle theta. Here's angle theta, here's the adjacent side. The opposite side, on the other hand, is directly across from angle theta. So if you see angle theta, you know that the leg directly across from it is the opposite side. And finally, the hypotenuse is the long side that is directly across from the 90-degree angle. Now, if you have not memorized the names of these 3 angles, do it now. It's that important. I'll even pause for a second so you can go do it. Okay, welcome back. If you have memorized these, then you're now ready to learn about 3 incredible trig functions: sine, cosine, and tangent. Notice that each of these functions has an abbreviation. This is not pronounced sin, it's pronounced sine. Everybody giggles about that. It's not sin, it's sine. Cosine is COS, and tangent is just tan. The important thing you need to remember about these functions is the fact that they each are used to express a ratio of the sides of a right triangle. Now, please be aware that these 3 functions are the main functions covered on the ACT math test. Other trig concepts may be covered as well, but probably not as much as these 3 functions are. So, accordingly, we're going to spend the rest of this lesson just learning about these 3. Let's start with the sine function. Here's what you need to remember. The sine of angle theta, this angle right here, is equal to the length of the opposite side divided by the length of the hypotenuse. So whatever the length of the opposite side is here, we put that in the numerator. Whatever the length of the hypotenuse is, we put that in the denominator, and then perform the division if we need to. Consider the triangle that you see right here. Given its dimensions, what is the value of sine of theta right here? Well, we know we need to put the opposite over the hypotenuse. So in this case, sine of theta equals 3 over 5. If we wanted to, we could divide this out. 3 divided by 5 equals 0.6. Now let's talk about cosine. Here's what you need to remember. The cosine of angle theta, whatever theta happens to be, is equal to the length of the adjacent side down here divided by the length of the hypotenuse. So in this triangle, the length of the adjacent side down here is 4. Remember, the adjacent side is right next to angle theta. And the hypotenuse is the side directly across from the 90-degree angle. So it's equal to 5. And if we do the math, 4 divided by 5 equals 0.8. Finally, we need to look at tangent. Here's what you need to remember. The tangent of angle theta right here, whatever it happens to be, is equal to the length of the opposite side divided by the length of the adjacent side. So in this example, the length of the opposite side is 3. The length of the adjacent side is 4. We don't need a calculator to figure that out. That comes out to 0.75. Now, here's an important point that I hope you noticed as we reviewed the definitions for these three trig functions, sine, cosine, and tangent. Here's what you need to remember. It actually doesn't matter how long these three sides are. As long as the measure of angle theta right here stays the same, then the ratios between the sides have to stay the same too. Notice here that I've taken the triangle we were working with previously and I've stretched it to twice its original size. However, angle theta right here, whatever it is still the same. Therefore, the ratios between the sides will still be the same as well. Don't believe me? Let's go ahead and calculate sine, cosine, and tangent again for angle theta in this bigger triangle. So sine of theta equals opposite over hypotenuse. Opposite is 6, hypotenuse is 10, which equals 0.6. That's exactly what we got before, isn't it? How about cosine? The adjacent side is 8, the hypotenuse is 10, 0.8. Once again, exactly what we got before. Tangent is equal to the opposite side, 6, over the adjacent side, 8. 6/8 reduces down to 3/4, which equals 0.75. Once again, exactly the same as we got with the smaller triangle. Even though the lengths of the sides are different, because angle theta down here stayed the same, then the ratio between the sides stayed the same. Now, before we end, I need to emphasize again how important it is that you remember how to calculate these three ratios, sine, cosine, and tangent. Now, there's a mnemonic that's been around for decades that I think is very helpful when you're trying to remember which ratio sides belong to which trig function. It's Sohcahtoa. If you can memorize Sohcahtoa, you're in good shape. Here's what you need to remember about this mnemonic. So, in Sohcahtoa, stands for sine equals opposite over hypotenuse. So if you're trying to calculate sine on the ACT math test and you can't remember what it is, just think so in Sohcahtoa. Sine equals opposite over hypotenuse. Same for cosine. The ka in Sohcahtoa stands for cosine equals adjacent over hypotenuse. And then finally, toa stands for tangent equals opposite over adjacent. If you haven't memorized Sohcahtoa yet, do it now. If you do, you will find that it's a lot easier to remember what the ratios are, which can be very valuable on your ACT math test, I might add. Now, before we end, please be aware that there are several angles commonly used with triangles on the ACT math test. These are the measures of angle theta. 30 degrees, 45 degrees, and 60 degrees. Now, I'm not guaranteeing that the triangles will use these measures, but it's very likely that they will. Now, you could manually calculate sine, cosine, and tangent manually for these various angles. However, you could save a lot of time just by memorizing them beforehand. Remember, time management is absolutely critical on the ACT, so anything you can do to save a couple of minutes will free up those minutes for use on harder problems. I strongly recommend that you commit this chart to memory. If angle theta equals 30 degrees, then sine of theta is 1 over 2, cosine is the square root of 3 over 2, and tangent is the square root of 3 over 3. Now, it doesn't matter, remember, how big the triangle is. It could be little teeny tiny or it could be ginormous. If within that right triangle theta is equal to 30 degrees, you already know what sine, cosine, and tangent is. You don't have to waste time manually calculating it. The same holds true if the angle is 45. If theta is 45 in a right triangle, then sine is the square root of 2 over 2, cosine is the square root of 2 over 2, and tangent is 1. If angle theta in a right triangle is 60, then sine is the square root of 3 over 2, cosine is 1 over 2, and tangent is the square root of 3. That's it for this lesson. In this lesson, we gave you a very brief intro to trigonometry. We first talked about what trigonometry is. We then looked at the sine function. Then we looked at the cosine function. Then we looked at the tangent function. And then we looked at several trig shortcuts you can use on the ACT math test.